Welcome to this session. This is the second session that we are going to be taking on Python, which means that it's basically a continuation to the previous session. Now, this is a pre-recorded session because we know that you all have exams, and even we were not really available during those times when all the people would be available. So I recorded it at a different time, and I'll be upload. I have basically uploaded this session on YouTube. So today we are going to look into conditional constructs, if-else statements, loops, functions, lambda functions. Lambda functions are also called anonymous functions, map function and map function and filter. Okay, so let us begin with conditional constructs. So I think while we were doing JavaScripts, we did discuss those operators which were used for comparing two quantities. So by the way, there are two ways of leaving a comment in Python. First, if you want to leave a single line comment, I think this was discussed in the previous session, but I'm going to discuss it anyway. So this is a single line comment so this is a comment. Okay, so you can see, okay, let me write anything right now. So anything I write without a pound symbol is or like a multi-line comment symbol is considered to be a part of the code which has to be read by the program. So this part is not going to get ignored by the program. In fact, you'll get an error when you try to run this because this doesn't really make any sense right now. That's why you'll see our problem was highlighted over here. Okay, and yep. So this is how you leave a single line comment with the pound symbol. And let's say you want to leave a multi-line comment, then you'll do something like this. You'll open the multi-line comment with three in double inverted commas and close it with three double inverted commas. You can also do single line commas like this. So let's say I write something over here. This is a comment. This is a comment. Now let's remove this so that we don't get an error. And I'll save this, and I think you all know that how to print something in the terminal and the output screen using Python. So I'll write hello world, and then I'll run the Python file, and you can see that the only thing we get right now is hello world, which we wrote over here. We didn't get any of these three things which were comments. So yeah, and like you can write anything over here. This is a line, and you get the point, right? And similarly you can do over here. This is also a line. So this is how you deal with comments, and I'll comment this out. Now we move on to conditional constructs. So let's get back to it. Okay, so we did discuss some comparison operators, and we are discussing JavaScript. So I'll also do the same for Python. Now some of the operators for comparison operators for JavaScript are not really there in Python, but nevertheless, let's discuss those which are there right now. Now, I am not discussing all the types of operators. We also have bitwise operators and other types, but we are only going to deal with the basic ones which you will need while using Django. Okay, Django or Flask or any other Python framework for doing web development. So this is the comparison operator. Wait, let me. Right. Okay. So okay. So this is the comparison operator, double equals. So example could be right. So I can compare. Let's say a equals. So let's say a equals to 20, and b equals to 100. Now let's say we want to compare it whether they are equal or not. So we will do print a equal to b. Now you know the output should be false because 20 is not equal to 10. Now let's try to run this over here because it's in the comment, won't get read by the program. So let's do this. If we are getting an error, why are we getting an error? All right, so we didn't really, we'll have to use this over here as well. Okay, so now this is fine. And now I'll run the Python file. And you'll see we get false. So basically, A equal to B returns either true or false depending on whether the condition is being met or not. It checks whether they are equal or not. So if it's equal, it will return true. And if it's not, it will return false. That's why it when I put this inside the print function, it printed false. Okay, I'll comment this out right now. All right, and now let's go to another operator, not equal to. Not equal to. Okay, I don't really remember the name exactly what it's called, but anyway, not equal to. So let's look at an example. Oh wait. Okay, so let's take the same example and do this, right? And we'll change this. So what not equal to does is it returns true if the condition, let's say we are checking, we know that A is not equal to B, and basically exclamation is not and equal to is where compare is basically equal to. So it checks whether it's not equal to or not. So A is not equal to B. We know this is true. So this evaluates true. Let's say if A was equal to 20 and even B was equal to 20 and we use this, it would return false because then A would have been equal to B. Okay, now let's try printing this and you will see that we get true, right? So this is how not equal to operator works. Now I'll comment it out and move on to the next comparison operator. Less than and greater, less than and greater than. Okay. I think basically everyone would be everyone has an idea about what's less than or greater than operator because uh, this is commonly used in mathematics. So yeah, and let's see an example. Right, I take the same case. Okay, and let's try this. Okay, so we know that A is smaller than B, which means A is less than B. So basically the condition is being satisfied. So this should print true. Whereas we could have when if well if we did this, this is a totally this one is a totally different one. Then wait, I need to write this actually. So let's say we did this, but we know that B is greater. So this the second one should return false. Okay. Basically these comparison operators basically work on the principle of returning true and false depending upon whether the condition is being met or not. So let's try to run this. Okay, so as you can see, we get true for the first one and we get false for the second one because that's what the equation evaluates to. So this is greater than and less than. Now we also have greater than and equal to and less than and equal to. Okay, so A is equal. Let's say we have. We'll take two more variables this time. We will take C equal to 100 and D is equal to 20. Oh, not 20, 98. Okay, so these are the four cases right now. Actually, I'll pick one more. 90. Okay, so these are the four variables we have right now, and I'll write greater than less than equal to and less than or equal to. And don't confuse with the slash. I'm putting the slash so that I can show that these are two different operators. Okay, slash here is not an operator. Slash a single slash is for division, not float division. So basically, you get a floating point answer. I hope you know that by now. And okay, so let's try doing a is greater than equal to d. Okay, so and then let's do e is greater than is greater than equal to a d. Let's just go with d, and now let's try c is greater than equal to b, and b is greater than equal to b. Okay, I'll comment this up at first, and let's check this. So we have assigned these values to these 5 variables which we just declared. And okay, so what greater than and greater than equal to or less than equal to works is, so basically if you have two values and you're comparing them, so in case the one which so let's say over here we have a is greater than equal to d. So if say a is greater than d, it returns true, but it will also return true if a is equal to d. Similarly, if C, let's see this one, if C is less than B, then it will return true. It will also return true if C is equal to B. So this is how it works. And now let's copy this and paste it here, and let's see the output. And right, so you can see the output over here. We got true for each of these cases because in each of these cases the condition was being met. A is greater than equal to d. A is not greater than d, but a is equal to d, so we got true. E is greater than equal to d. Obviously, E is 90 and d is 20, so we are getting true. For the third one, C is less than equal to b. No, C and b are both equal, but so we got true. And as for the fourth one, d is less than equal to b. Yes, d is in fact lesser than b. D is 20 and b is 100, so that's why we got true. So I think this is clear right now. So there would be a fundamental difference between less than and less than equal to. I think you might know that by now. So if we do a is less than equal to d, you will get true because both are 20. But if you do a is less than d, so you'll get false because a is not less than d. Both of them are equal. And this point is clear by now. And so I'll move on to the next bit. Just give me a second. I'll be looking to what I need to discuss next. Right. Also, one thing, do keep in mind to keep these conditions in like brackets because it helps to separate them from the line of code. So it makes it easier to read them and understand them if you're comparing a number of things in just one line. And now that we have discussed these logical conditions, and so I'll move on to loops. Okay, no, not loops, conditional constructs. So just like we had conditional constructs in JavaScript where we were comparing certain conditions and like a block would run if the conditions for that block met. Similarly, we have loop conditional constructs in Python. Now okay. So if say we have so okay, and the syntax is if condition execute code. No, this is not if not is. No, this is not a rigid syntax like the way I'm writing it at least. I don't think this is correct way to write the syntax, but I follow this. Uh, but like the application is correct. Right. Okay, so how this works is, let's say you have a certain condition over here. So you have this entire thing. Now this entire thing won't get executed. You'll have a condition over here and the if block. So you'll basically saying if the condition is being met, then you move on to this block, and whatever is over here, you'll execute this. And if this condition returns false, which means you won't be executing this block, then you'll move on to this one else block, and you'll be executing the code over here. Now this is just if you want to have one condition, but let's say you want to check for a series of conditions. So like if this is being not met, then you check this. If this is not being met, then you check this. So kind of that approach. The code is very similar once again. And elif. Okay, so I think if you have come from C++ background, or even this was in JavaScript, so we have if, else if, and if. But in Python, we have elif instead of else if. So I write else elif and then condition, and the code over here. And you can obviously have multiple elifs. I'll just put one over here for the syntax. And right. So this is the structure. And so it will first check the if block. If the condition is true, then it will execute this one, or else it's going to move on to the elif block. If the elif block's condition is true, then it will execute this, or else it will move to the else block. Now you'll see that the elif block has a condition, but the else block doesn't. The else block is the last resort. Basically, nothing is being met, so you will move on to this one. But let's say any of the conditions above it is being met, then that block's condition is being executed. Which means, so let's say I think I explained it, but again, so if the condition for this block is being met, then elif and else won't get executed. If elif's condition is being met, then it means that the above condition was not being met. So that conditions block was not getting executed, and similarly the else block is not going to get executed because the program didn't really have to jump onto that block. So this is the basic syntax. Now let's look at an example. Now let's say name1 is equal to Shivansh, and name2 is equal to, actually we'll not take name, we'll take numbers. Num1 is equal to 10 and num2 is equal to 20. Right. And okay, so this one is for this thing. I'll be demonstrating this one first. And right, so we'll do if a is greater than b, print a, else print b. Okay, so I think this code is very simple. Okay, wait, this is num1, num2. Right, I think this is the code. And okay, so we have two variables, num1 and num2, with values 10 and 20 respectively. We are checking this condition. Okay, so I told you all to you put them inside the brackets. Now putting them inside brackets is not really necessary, but I will suggest it so that it's easier to read the code. So if num1 is greater than num2, then print num1, else print num2. Okay, so num1 is definitely smaller than num2, so I think the else, so not think, I'm pretty sure that the else block is going to get executed, as you can see right now. So you'll see num2 got printed. But let's say num1 was equal to 100, which means that the first block's condition is getting satisfied already. Then you'll get the output as num1, right? So this is how it works. Now let's check if elif, right? I'll comment this out, right? A is equal to 20, b is equal to 40, c is equal to 80. If a is greater than b, print A greater than B, elif B is greater than A, print. Actually, we'll just okay. Print B is greater than A. I don't know why I used the third variable, but anyway, else print I don't know. Okay, I wrote print I don't know. Okay, so A is 20, B is 40, and C is 80. If A is greater than B, now A is definitely not greater than B, so this block is going to get skipped. But B is greater than A, so this one is going to get executed over here. No, I don't think C is needed over here, so I'll just remove it. Okay. So you can see that B is greater than A is getting executed like I told you all. But let's say A is 200, right? Which means that A is greater than B. So the first block is going to get executed right now. E is greater than B, right? Okay. Now let's keep this as 400, and right, let's do this. A is not greater than B and B is not lesser than A. We know that, and like so this means that these two blocks are getting skipped and the else block is getting printed because that's the last resort over here. So you'll get the output as IDK, which means I don't know. So that is how if elif works. And okay, now we can have we can compare multiple conditions together, obviously, which means that we should get true for all of those conditions under that block, or else it's not going to get printed. So let's say we have A equal to 1, B equal to 2, C equal to 3, right? And we'll check. But now this is this is an example where you will need to put these you'll need to use this. It's not really necessary, but it's suggested because it's going to make it much more clearer. Okay, right? And what's the function of pass, by the way? So if you have an if else block and nothing's inside, so you'll get an error. If I try to run this, it will throw an error. Okay, so indentation errors. So basically, it expected something which was getting run over here after the indentation. And by the way, in Python, you don't have curly brackets inside which you write the code for if else blocks and loops or functions. Instead, you have an indentation. So if you move to a sub block, you give an indentation using the tab key on your keyboard, and then that's how you enter the sub block. Okay, so using pass, like the keyword pass, I can avoid that issue which I just got, that indentation error issue, because this is basically going to pass this block. That's basically how you tell Python to ignore that nothing's really there to run and just avoid that block. Right. So now you can see that this got run pretty conveniently. And now let's try to check this. Okay, so if A is greater than B and C is greater than B, print hello, else print bye. Okay, so C is greater than B. We know that this part is true, but A is not greater than B. A is lesser than B. And we know how AND works. AND basically requires that both of the conditions are true. So we have one false and one true. So the resultant is going to be false, which means that this block is going to get avoided and the else block is going to get printed. So you get the output as bye. and let's say I had done this, and then I had run the program, I would have gotten hello because now both of the conditions are true. So this was if else and conditional construct. I think this part is going to be pretty clear right now. Let us move on to loops. Now, what's the purpose of using loops? So I think we have discussed certain. I don't think like not really think, but like I'm pretty sure we discussed it while doing JavaScript. So loops are basically used when you want to do something repetitive or if you want to uh, iterate something. So there are two types of loops in Python: while loop and for loop. Now the while loop is also called conditional loop because you pass a condition and the loop keeps running until that condition is met. As a for loop, it's called a counting loop because it runs only until a specific number a specific range is provided. Okay, and right. So I'll begin with while loop. Right, while loop is your conditional loop or while loop. Now, what's the syntax? While condition code. Okay, so this is the syntax, is not the most accurate syntax, but this is what it looks like. So while this is your condition, so while this is not satisfied, you will run this block. Okay. So like generally, you will use while block um, if you want to run a program infinite number of times. So let's say we know that a block is going to get executed as a block only if its main block is true. So let's say I wrote a is equal to b and b is equal to no not b, c is equal, what did I write? A is equal to 20 and c is equal to 10, right? Now what I'll do is while c is less than b, print c plus equal to 1. Okay, so this means that as long as c is lesser than b, you'll print the current value of c and then you'll increase the value of c by 1. Now let's try running this. Or all right, we have a not e. Okay, now let's run this. So you'll see we get all these values all the way from 10 till 19, which is because 19 is after that 19 will get 20 and 20 is not less than 20, so the loop breaks. So this ran until that condition was being satisfied. Okay, so you can see why we called it a conditional loop. Okay, but let's say we wanted it to let's say you wanted the loop to break uh, if say c was divisible by I think the modulus operator is known. So 9. Okay. So c mod 9 is equal to 0, then break. So what's break? Break is basically break is used to break a loop before it gets completed. So this loop should break before printing 19. Right. Right now it prints from 10 to 19. But C is divisible by 9, so none of these are divisible by 9 except for 18. So we'll get till 18 and not 19 because we put this inside the loop. So let's check the output. Okay. So as you can see, yeah, we didn't even get 18 because you can see that we increased the value before uh, putting this. So once 17 got printed, the value became 18, and it checked whether 18 was divisible by 9, and yes, it was divisible. That's why it broke it. Let's say it was above this. Now I think 18 would have been printed. Yeah, you can see over here now 18 gets printed because it prints 18 and then it checks. Oh wait, it is 18. So what it does is it breaks it, and this is how the break statement works, break keyword works, and you can also use this for loop, obviously. And yeah, yeah, and this is one way to use while. Now let's see, you want the loop to run infinite number of times. I could have done uh, while, let's say I'll do a is equal to 10, 20, while a is equal to 20. Now this obviously is a true condition, and I'll do hello, right? And I'll run this. Now you can see hello keeps getting printed infinite number of times. The loop is not going to stop because you have not written break anywhere, and you are not, and this condition is being satisfied eternally. So this will keep running, and don't try this, by the way, your computer could crash. So yeah, this is one way to run an infinite loop. But let's say you don't want to use it like this. You can also do while true print hello. Now why are we writing true? Now we know a double equal to 20 is returning true because a is equal to 20. So technically it's while true that you print hello. So instead of having all this like a equal to 20 and a double equal to 20, I'm just writing while true. So as long as it's true, it's running this block. And you can see the output, it keeps running. And let's say, and if I use break, then it will stop after one time. Right. So this is how you use this thing. Okay. Now let's try something. I'll try to create a block example. So now let's try this. Okay, so you do while true. So you want this block to run as long as it's true. And okay, let's try this. A is equal to input, enter a number, and then I'll do same thing, enter another number, and we'll do this. Print a plus b equal to a plus b, right? So we are printing the value of a plus b, and I'll use break over here for once, and now check the output. Okay, so I'll enter 109 and 10, let's say. A plus b is equal to, that's right, I didn't use int. Basically it takes a string as an input, so I'll have to convert this thing to an integer using int. And right. And now if I run this, 10, 20. So we got a plus b equal to 30. Now I use break, that's why I didn't keep running infinitely. Let's say I remove this and I run this now. 10 and 20. So we get 30, but it'll move back to this loop again. And it'll again ask you for a number. But let's say you don't want this to happen all the times. Let's say you want to exit the loop at a certain point. How do you do that? So you can do something like this. Right, and keep, so this is my variable keep running. Do you want to stop the program? And I'll use y comma n as a way to do that. Okay, so right, so if you want to stop the program, you'll write y, or if you want to keep it running, so you'll write n, and I'll use this, by the way. So dot lower is basically a string function, string method, which basically converts the entire all the letters in the statement to a lowercase letter. I'm using this because let's say a person enters capital Y, then it would not be interpreted correctly if I didn't really have the dot lower head. So I'll check if keep running is equal to Y break else pass. Pass Y, because I don't really want to write anything over here. I just if it comes to this, I just want the program to run. I could have also skipped this, by the way, but I'm going to keep it over here. So I'll do this. And by the way, n is not really required over here. Or actually, let's do this. I like writing it in this way. Elif keep keep running is equal to n, and what it does is it passes it. Right. So okay. So you have you'll be taking two numbers a and b, and you'll printing a value of a comma a plus b. Then you'll ask the user whether they want to keep running the program or not with y and n. Since it could be capital or small, you don't know. We are using this method to convert it to small caps, and then we are checking this. If they say yes, which is y, then you break the program. If they said no, they want to use a program, then you use then you there's this block. We didn't write anything because we don't really want to print anything. We are just using the pass keyword so that the program doesn't raise in, so that there is no error. And if and after this is run, it returns to the top of the program. And else, so basically, if you write y and if you don't give the valid input, which is y or n, then it says invalid input free running the block. So these two blocks are these two conditions are these two valid options are not provided. You are providing, let's say, any weird sort of value. So this is a way you could handle error in a block for an input. So this block is going to run if you don't enter y or n. So I'll run this. Right, I'll enter 10 and 20. It'll wait. Hmm. Right, this error. Okay, we got a plus b equals to 30, and now do you want to stop the program? No, I don't want to stop the program, so I enter n. So it passes on and the block is rerun, and now I'll enter 20 and 20, we get 40. Do you want to stop the program? I enter something weird. Now I entered this, but this is not a valid option. So it says invalid input, rerunning the block. Okay. Now enter 10 and 30. It prints 40. And you want to stop the program? Yes, I want to. I enter Y, and then it exits the program. So this is how this thing works. I think this is very clear. So basically, we use a loop, and we use a loop inside which we have which we were taking two numbers and printing the sum, and then we are checking whether the user wanted to keep using that while block, which was the entire program in this case. Okay, now I also want to introduce this keyword called continuing. Okay, now continue can also again be used for loop, while true. Okay, and I'll comment this out at first. Right, a is equal to 10 while a is less than 20, right? If a modulo 3 is equal to 0, print a is divisible by 3 is elif a modulo 9 is equal to 0. Continue. Else pass. Okay. So how does this program work? Okay, then this is not complete. Q plus equal to 1, right? So you have a variable a is equal to 10, and you're checking where this program runs until a reaches the value of 20. So it checks whether a is divisible by 3. If a is divisible by 3, then it prints that value of a and says is divisible by 3. Now let's say it checks also divisible by 9. Now we know that 18 is divisible by 9, but 18 is also divisible by 3. So what do you think will happen? It will check whether a is divisible by 3, right? It is divisible by 3, so it will execute this block, but it will uh, ignore these two blocks. But let's say a is not divisible by 3 or 9, then it will check this one, else pass, which means nothing is getting printed. Check the output, right? Okay, so technically you should have gotten 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. You got 12, 15, and 18 because these are divisible by 3. And why did this block not really work? Because 18 was divisible by 9, but then 18 was also divisible by 3. Right. Let's change the conditions a little bit. 9. And let's say we write. Okay. And now I'll kill this one and like rerun it. Okay. And you can see there's no output. Why is there not? I hate this. I think I have found out why this was not really working. So basically, it checks the first block. Now this is only possible when a is equal to 18. So after 10, so like 10 is not really being accepted by the first block. For the second block, what it does is it uses continue. So what continue does is it skips the rest of the block and jumps back to the start of the block. So which means that a plus equal to 1 was not really done. That's why the program didn't give us any output. It took me a minute to realize that. Yeah, I got a little confused, but okay. So let's move this over here, and now let's read on the program. And now see, you get the, wait, I'll change this actually. This is 9, right? Yep. So you can see that we got the output 18 is divisible by 9. But for print, I'll even do this actually. Print diff by 3. Okay. So we were having 3 values, 12, 15, and 18. 18 for 12 and 15, we got div by 3, which was this block, and then it used continue. And then it jumped over here and it increased the value by 1, and it entered this block. Since 18 was divisible by 9, this block got executed, and then the program continued. But let's say I had shifted this over here. So once the program had reached 3, you can see what happens. The value doesn't really increase for a, and the program keeps on running. So just be careful with this. You can see even I ran into some issue because I didn't really think how I was using it right now. So just be careful with this. Right. So this is how continue works. Basically, continue skips the rest of the block and jumps back to the top of the block. Now let's move on to for loop. which is also known as your counting loop. For loop or counting loop. What's the syntax? For condition. Cool. Okay. So this is the syntax for loop for condition. Right. Now, let's say I have a equal to 120 for I in, I'll use this for I in range A. Actually, this. Okay, now this might look confusing to you, but it uses a similar principle like this one. So what this does is you have a variable called a equal to 12. Now the range function basically, the range function is going to return a list of those numbers. So let's say I had done this. Print range 12. Let's say I had done this. Right. I'll have to convert this to a list. Okay. Okay. Now, the reason this worked over here is because you don't really need a list. It returns the position and it works. Right. So list change. So you will. So what this does is it converts. It returns 0 to 11 at a location and use the list function to convert it to a list. I'm just using the list function over here so that I can demonstrate how range works. You don't really need to write list over here because you saw that you'll see that the program runs without it. So it returns a list, like in this case at least, and you know that uh, for a variable that is a value in this list, this block is going to get executed. Okay, so what I does is I is a variable for that block for running that block. So I is usually set to 0 if you're not really like if you are using the range function, at least it begins from 0 by default. You can obviously change this value. So I have this a is equal to 12 for I is in range a. I in range a, which means now by the way, the max value is 12, but it is never going to run till 12 because we know that the last value is avoided. So for I in range A means as long as I is less than 12. I is starting from 0 and running as long as I reaches the value 11. Now let's check this. Okay, it should have written I, not A. Right. So this begins all the way from 0 and goes till 11, after which the value increments for I and it reaches 12, which means this block is not going to get executed. Now over here you had to use this for increasing the value of A, but but in this case you don't really have to increment the value of I manually because the for block does it for you by default. It increases the value for I by 1 if nothing is being specified. Now let's say you want to you wanted the program to start from 1 and run till it reaches A. Okay, so in this case, what would happen? This would have been your output. Now you saw that all the way from 1 to 11, those things were same, only 0 didn't get printed because you began the value of I from 1. So this is how you can set a value for I yourself. Otherwise, by default, it is set to 0. Okay. Now let's say you right now the increment value for each time is 1, but let's say we wanted it to be something else. Let's say I wanted it to be 2. I would have written this. So this is the I call it skip count. Basically number you want to add to I after the end of the loop, after end of each iteration, basically. So we have this 1, 3, 5, 7, 9, 11. So all the even numbers are getting avoided because the loop begins from 1. Had it been 0, which is the default value, you would have gotten 0 to 4, 6, 8, 10. And let's say it is 0 right now, and this is 1. So this is by default. Okay, so if your conditions are as such, you could have easily avoided writing 0 and 1 and just written a. So this is your standard case, and you can see you get from 0 to 11. And obviously I can break it in the middle. If I is equal to 10, break, right? And I'll run this, and this broke once I reached the value of 10. So 11 didn't get printed like it was getting printed over here. Now I could have also done else print, oh, hello. Okay, you can see this. I can change it furthermore. I'll just comment this out, and I'll write if let's say I is equal I modulo 2 is equal to 0, and then continue. Right now, this does this. Wait, I'll have to actually put it over here. Right. So this printed all the odd values because 0, 2, 4, 6, 8 are divisible by 2. So the bottom block is getting skipped. So this is how you would use break, continue in case of for and while loop, and you have seen how the range function works. And this is the basic structure of. Okay, now let's see another example. Right, let's say A is a list 1, 2, 3, 4, 5, 6, and then I did for I in A, right? Print I. Okay, right. Now what this does is it prints all the elements inside the list. So in this case, what happens is, and in this case is very similar to this one as well. That's why I showed you the list when you use range A and then convert it to a list using a list function. The logic is same. I is assigned. So if A is a list or a dictionary or any other iterable, what it does is it assigns the first value of that iterable to I, and then goes on accessing all the subsequent values of that iterable, unless you obviously uh, tell the code to like skip a few. So yeah, this is how it works. So when I did for I in A, first it started from 1, it printed I, and then it moved on to the second one, it printed 2, and that's how it continued. I could have also done um, for let's say B is equal to, no, this is a tuple, by the way. For I in B, print B, right? By the way, the reason why I am using I again without any problem is that this is temporary for a loop. Okay, this is only for that loop. If I'm using it outside that loop, then there's no problem. But let's say I use that value of I again inside that same loop, I would have gotten an error. Okay, right. Uh, Wait, I'll print I not B. So this is your for you. You're getting this for this one, and for the tuple, it works with it works in the same way. You're getting all the elements of the tuple over here. Okay. Um, I'll also demonstrate it with a dictionary for I in dict print uh, print I. Right. Uh, okay. Dict equals to, let's say, name my name is and age is 17. Sex is male, and okay, I think this much is fine. And yeah, I'll comment this out right now. And this is my dictionary. These are the keys and these are the values. I hope you all know what a dictionary is. A dictionary basically maps key value pairs, and what it does, like by default for I indict, it'll check the keys. It'll ignore the values. So it sends a list of keys, which is name, age, and sex, and it prints the value of I is either name or age or sex. So it moves from name to age to sex, and like it'll print I this, and then I'm writing this, and I'm writing the value of that uh, key, right? Hmm. Okay, yes. What we are getting that error. I'm concatenating, that's why I'll just convert it to a string. Right. So you can see the output over here. So this is how it worked. Right. So this is how it works. And now I'll also show it for a string, by the way, since a string is also an iterable. This could you could use this to like check strings. Let's say A is my name is Gaurav. This spelling wrong. Right. For I in A. So for I in A, right, I missed I. So basically for I is basically moving from one character to other character. So it will move from M to Y to the blank character to N line like that. Uh, so if let's say ordinal of I is divisible by 2, print ordi comma is print I. Right. Check this code. Hmm. Right. So by the way, what is ORD? It returns the value. I'll actually show this. And channel image. So ordinal is one of those functions which you could use to find the ordinal value of your character. I think you'll know about the ASCII and Unicode encoding and all of that. ORD in I. in case you're a class 11 student or a class 12 student, you will know about ORD already, because this is taught in the computer science curriculum. And right, so this is how it works. So ORDA returns the Unicode value of A, right? Uh, and you can have other functions for returning the binary values or the ASCII values. And by the way, capital A and small a would have different Unicode values, because that's how they are identified as being different, right? And you can also have functions such as CHR, which returns the alphabet if you provide the alphabet, or the symbol if you provide the Unicode value. So what I did was I checked ORDI, which means I checked the Unicode value. If it was divisible by 2, I printed the Unicode value as well as the character for which for which the Unicode was divisible by 2. In case it was not, then I just printed the characters. So yeah, you can see this over here, M, Y, and 32, and then 10N, and like all of this. So this is how it works. Right. Okay. So, or if you didn't want to do this, if you just wanted to print all the characters, you would have done print I, and then this does this. My name is Gaurav. Now, why is there a space over here? This is because an empty character is also considered to be a character. That's why. Right. Now, I think I have discussed loops in quite a bit of detail. Acha. Also, let's discuss how this thing for I in range. Let's say your loop begins from 14 and it runs till 0. Okay, do you think this is going to work? If yes, then you're correct. This is going to work. We are changing the skipping value. We are basically moving backwards. We start the loop from 14 and go till I reaches 0. We are using -1 to decrease the value every time. Right. 14 was included. Obviously, the first value is included. Now 0 cannot be included, so it gets printed only till 1, after which the loop breaks. So this is one thing that you could try. Uh, okay, and now we will move on to functions. Now, what is a function? A function is basically a block of code which only runs while it is being called. So you can pass data known as parameters into a function, and a function can return data as a result. A function doesn't really need to return anything, but uh, generally you will use a function if you want to separate your different blocks of code from each other, or like if you want to use something in multiple places, so you don't want to write that same code again and again, because it increases the file size and the number of times you're using. So you just write a function and you call that function every time you want to use it. Okay, I think that makes it clear, and I'll show you what a function, how to define a function in Python. um, a function is in Python is defined using the keyword def. Def means it means define, I think. Def function. Okay, I'll first show the syntax. Functions and def function name. Code. This is how you define your function, and let's say you wanted to call that function. So you would have done, depending on whether it has parameters or not, you would have done function name. This basically calls that function. Right, now let's see. Okay, so let's say you want a function to return the sum of numbers, sum of numbers. Okay. Right. And by the way, you need to put these parentheses or else it will not work. Right. Okay. I'll use the pass keyword. Now you can use the pass keyword for functions also, so that you don't get an error if there is no code inside that function. Uh, let's say I'm accepting two values, a equal to int num1, b equal to int num2, right? Okay, let's first demonstrate an empty function. What an empty function looks like. So this print is also a function, by the way. So if we say first, let's do this, by the way. I'll do sum of num. Okay, and let's say I am doing a is equal to 12 plus 12. Sum of num, when I'm writing this in the main body, I'm basically calling this function, and which means that the code inside is being run. So a is equal to 12 plus 12, which means 14. But we will not get any output because we are not printing the function, or there is no print statement inside this. Let's say we had this, then we would have gotten 14. Not 14, sorry, 24. Because we are printing that with the function as well. So this code is getting run. Let's say I do a is equal to 12, b is equal to 13, c is equal to a plus b. Now let's say I don't want the now let's say I don't want to print the value of c from inside the function, but I want to send that value of c to the main code, and then use that value over there. So we will use the return keyword and then write c. So what it does is it returns the value of c. Now, why are we returning a value of c? A function, basically what is inside a function is stored inside a function, is a part of that function only unless you return that value. So if we had, let's say, c is equal to sum of num this, let's say we run this, and we are not including print over here, by the way, right now, and I'm going to write print c. For the sake of simplicity, I'm going to write num over here, and let's say we don't write this for now. Okay, so by default a function returns none keyword. Okay, none is not a keyword, basically none is a value. So none means it is not returning any value, any specific value. So you see the value none. So when we did assign the value of this function, which returns the value none to this variable num and then printed num, we got none. But let's say I was returning c, then I would have gotten the value 25 from here, and that value would have been assigned to the variable num, and then I would have printed. This can become difficult to understand. The return keyword is basically, so to keep it simple, the purpose of a function is to do something separately so that it doesn't get mixed up with your main code. But your main code does need the access so that it can use it later on. So let's say you take two numbers as input from a user, and then you want to calculate the sum of numbers. Let's say you're building a calculator, so you have different operators. You take in the two numbers or three numbers or whatever, and then you also take the operator, and then you want to calculate something. And so instead of creating the what you will do with the different operators, you can create def sum of number, difference of numbers and all, and inside that function you will pass on those values You don't really need to pass on a value if it's not a calculator, it's something else. But in this case, you will need to, since it's a calculator, you'll pass on those values to that function, uh, and then as parameters, and then inside that you do whatever you want to, and in the end you want to return that value, so that it can be printed. Now it can also obviously be printed from inside the function itself, but let's say you want to use it afterwards in some other area in the main code or in some other part of the code, then you will have to return it if it's if it's a part of the code outside the function. So that's why you return something. Now doing this, what it does is it calls the function. But let's say I did this. Now does it print any value? It returns the position of that function, the memory address of that function. So this is basically the hexadecimal memory address of that function, if I'm not wrong. Uh, okay, and then if you had you done this num parentheses, then you would have gotten this value. The reason being that you need these parentheses so that you can access the value at that position, right? So this is one thing that you need to remember. So okay, and right, and let's take an example where we pass on parameters. Let's actually take an example where we build a calculator. uh, Print welcome to the calculator. Print not actually print uh, a is equal to, we'll just do it for two numbers. A is equal to int input, enter the first number, and the second number. Okay, and C is equal to input, enter the operator, and we provide what all operators can be entered: plus, minus, this, and this, right? And okay, so if C equal to, let's say, plus, right? Okay, so these are the four operators that you are taking. So now let's define these functions. Def sum of num, okay, uh, and then def diff of num, def div the num, def mod modulo the num. Now, this doesn't really make any sense if you try to understand it, like the naming obviously, but you get the point of the program so far. Okay, so let's say, and we are only taking two numbers, so we'll be taking two parameters, a comma b. A comma b is the parameter. I'll tell what a parameter is just in a minute, right? And each of the functions can have its own parameters or cannot have a parameter, and the parameters can be having the same name. for different functions. That is not obviously for the same function. I cannot write a comma a for sum of num. I can obviously, but I can write a comma b for sum of num, and then also write a comma b for difference of num, because those are two different blocks. Okay, so this is a function. What is a parameter? So basically, you can see this is a variable in your main block, but you will need a parameter for a function if you are taking any value from outside. So any value is being used inside that function, being passed to that function basically is being passed to this variable. So let's say I did print sum of num a comma b, right? So what this does is it calls that function sum of num, and it passes these two values a comma b, which we will be taking over here, to this a comma b. Now don't confuse this a comma b to this a comma b. I'll do one thing. I'll change this to x comma y so that it's less confusing right now. X comma y. Okay, so the value of a comma b is being passed to this, and the operator is plus, in right, and then what this does is it returns x plus y. Okay, it returns x plus y to this. So let's say I enter 10 and 20 and plus operator, so it runs this block. It calls this function and passes these two parameters a comma b, and it returns this. Okay, it returns x plus y. Now similarly, I can write that code for these, and I'll obviously change the name of the functions, and modular now. Right. So this is our code right now, and let's say you enter a value which is not really valid as per the program. Print invalid, right? Okay, and I'll write the code. Return x minus y. Return x by y. Return x modulo y. Okay, and to like make this and this thing repetitive, I'll do while, and I'll write it like this, and input, and I'll also check whether the user wants to keep using it. Use more equals to input. Do you want to keep using the code? Y comma n, and I'll copy this over here. Just a minute. Okay. Do you want to keep using the program? Right. So let's check the code. Oh, I'll change this. Okay. So these are your four functions. For some difference, division, and modulo, you are taking two. Wait, is there an error over? I'm getting an error for some reason. All right, I'll have to write condition. Okay, so you are taking two values, and then you're taking the operator based on the operator here, and you're calling that function and passing on these two values as parameters to this function. And then you can see parameter x and then parameter y. And then you're returning the sum, difference, division, and module depending on what function you call. And and you're printing it in each case, and if it's invalid, then you're writing invalid, and then you are asking user whether they want to keep continue using the program, right? And yes, this is how it works right now. Okay, so welcome to the calculator. I'll actually make it more presentable. Wait a minute. This is one thing that you can do every time so that you're okay. So right, and then okay, so I made this tidier, like in terms of the presentation, and I'll come to the calculator into the first number 10, 20. I want to add, so I'm writing plus. I got 30, which is what I wanted. Do I want to keep using the program? Yes, I want to keep using the program. 20 and then 10. I'll use minus or 10 as expected. I'll use it again. 20, 10, float division. No, not float division, simple division. So 2.0. This returns a floating value, obviously. And again 20 and 10, and then I use modulo. So right, wait, okay, yeah, okay, so this was supposed to be modulo. Now let's run this 10 and 2, let's say, modulo operator. So this returns 0, remainder is 0, that's why I want to use it again, and I'll write 20 and 10, and then anything I'll get invalid because that was not really right. I don't want to use it anymore. I'll write n, and that's how I exited this program. So this is how you have a function. Now you saw how beneficial this was, right? Instead of writing this entire thing over here, and consider you have like 5 or 6 files and you want to use it across those 5 or 6 files. Let's say you're using modules for transporting things. So in that case, you can just have a file of all the functions which you want to use across multiple files, and then you can import those functions. Now we'll go on to imports later on, not right now, because that would be a lot to take in for just one session. But I think you all got the basic idea. Okay. Now I'll comment this out. Okay. And so this was your so the next function is map function. Basically I wanted to show lambda before map and filter, but I think it will be much easier to explain the lambda function if I am already demonstrating it with map and filter. Okay, so so map function is basically used to apply a function to all the values of an iterable, like generally. Okay, so for example, let's say we have a list master. This is just any list, and let's say it has value 1 2 3 4 5 6 7. Okay, let's say we want to convert all the items in this list to a string. Obviously we can use a for loop, but an easier way out is by using a map function. Okay, so I'll use list master is equal to, I'm updating the same list, list map str comma list master, and then we are going to print list master, and let's do this thing over here, list master. We are going to print list master over here as well. And now let's run this program. So you can see the output in these two cases. Before this line, the print over here is printing a list of numbers, whereas this one's printing a list of strings, which are basically numbers. Okay, so why is this so? right now all the elements of this list are numbers, so that's printing that. But what about this one? Okay, so this is happening because of the map function. The map function does is it takes two parameters, map, this is the function, and it takes two parameters. It takes the function to be applied, and it takes the iterable. Okay, so this is how your map function works. But like just writing, so like I could have, let's say instead of this, I could have done, obviously I need to store it somewhere. I stored it in the same variable over here, list master, but I would not suggest it. Uh, so like I would suggest making a new variable if you're using it somewhere. So I have written a equals to map. Let's say I want to, um, again I want to just convert it to string, and okay, and let's do list master type. Okay, so and then we do print a, and then we run this. Okay, so this prints the map object. Okay, so like just like in the range function, right, like how you could do a equals to range and enter that parameter, and then it would have returned the like the position, like where the range, the memory address of the range function. Similarly, like map function, using the map function returns the memory address, the map address, and of the memory address of that map object, and then you can convert it to a list so that the values are visible. So that's why if I do now list a and then I print this, then you can see I have those values. Over here, so like in the above case, what I did was that um, instead of like instead of writing this thing in the separate lines, I wrote list map all of them in the same line, and then I basically updated the same variable which had that list. So that's why it looks a bit different. And also, okay, so function. Okay, so what about the function? So string is, as we know, is a function, and like generally we know that to use string function we need to use the parentheses, but in case of the map function, as per the syntax, you do not need to put the parentheses, you just need to name the function. Okay, so this means, let's say okay, so I'll actually show that in a different in a different thing. Okay, and this iterables. Okay, so what if this was a tuple? Now, right, and you can see this works for a tuple as well, but you can see that the return value is a list. So that's something you need to be aware of. And now let's move on to filter. So as the name suggests, the filter function basically does the work of filtering things. So let's say we have this thing, list master list is equal to 1 2 3 4 5 6 7 8 9 10. Okay, so this is your list, let's say, and now I need to print that list. You can see this, right? So this is the output, and the and the syntax is filter, basically the same thing. And let's say I update that same list, and just like map, you need to convert the filter of like using filter returns that object address, and you use the list function to convert it to a list so that you can use it and like read it and all. Okay, and filter inside this, we enter the function, and let's say as far as the iterable, so I'll enter list And okay, so we need to enter a function for filtering. So let's say I define a function, I define my own function, uh, uh, def fill, and if like I take a parameter x, and if x modulo 2 is equal to 1, return x. Okay, so this is basically my function, and this is the function I'll be using over here. And now I'll run this. Oh wait, I need to print the list as well, right? And you can see that we got all those. So basically, we had this original list and we printed it over here. Now we have this variable storing a list. The list is converting the filter object's map address to the list, and then we are taking this function. This function is taking this iterable's values one by one. So what it does is, like you could have done this using a for loop instead of using filter, but basically every element in this list is passed one by one to this function. So like at first it passes 1 to this function and stores it in the parameter x, and then checks if x modulo 2 is equal to 1. If yes, it returns x. Now, which means 1, 3, 5, 7, 9 are going to get returned because they are their modulo with 2 returns gives 1. So this is getting stored in this, and now when we print that original variable list, then we get 1, 3, 5, 7, 9. So this is how filter works. Filter is basically to filter out things. Now again, this is a one-liner function, so I could have, so let's say I don't want to write a function separately. What do I do? Instead of writing, okay, so over here I'm going to demonstrate a lambda function. What lambda function is, I'll add lambda over here. Lambda function. A lambda function is basically an anonymous function. Uh, now you might ask why anonymous, because it's a one-liner function. That's why it's often called as an anonymous function, because it cannot be accessed anywhere except for that line. So let's say lambda x such that x modulo 2 is equal to 0, and now we run this. See, now okay, I'm putting one so that I can demonstrate the original one. Now, how does a lambda function work? Now, originally I was using that function, that def fill function. I was using the fill keyword over here to refer to that function. So instead of having a function outside, I'm just using this one-liner function. I'm defining a lambda function or an anonymous function. You need this keyword lambda, and then you need to define the parameters, like just like you do, just like I had done def fill, and then inside these parentheses I had x or like any other parameter name. I could have done y here, or like anything else. I could have also done fill, and I'll change this obviously now, and like I could have also done this, but you get the point. I think so. Yeah, so what it does is every element inside in this of this iterable is passed one by one to this new function x, lambda y, because it is not having a name, anonymous y because it doesn't have a name, and one by one the values are being passed to this parameter x, and now it jumps inside this function, and what it does is, instead of now over here you don't need to mention the return because it automatically returns this thing. So what it does is it checks x modulo 2 equal to 1. So if this condition is satisfied, then that value is returned to this list. So this is how it works. Run code. Yeah. And yeah, so you can see this output over here. So this is how a lambda function works. Now, doesn't mean that you cannot have a lambda function where you only have one parameter. Obviously, you can have more than one parameters as well. So let's say I have a is equal to 10, b is equal to 20, c is equal to lambda x comma y such that x comma y such that return, no, I don't need to return actually, x plus y. Okay, and then print c a comma b, right? I think this makes sense to you right now. And let's check the terminal. I'll explain this. Right. So this is just like a simple function. So you could have done this def c and then x comma y and then return x plus y. You could have definitely done this and then gotten the same answer 30. But instead of like defining a function, I'm just using a lambda function and doing that. So again, the keyword lambda to define the lambda function, and those parameters x comma y, which is taking the, and then it returns x plus y. So then I call this function c, and inside the parenthesis I pass on the parameters, which is a and b. So a is passed to x and b is passed to y, and it returns x plus y to this, and then it's getting printed. Now you might ask, why am I like, why to call the function I need to use this over here, but like in this case I just need to write this. That's because this would have worked. Like I could write c obviously, and you would have gotten the address. That's why you need to like specify this, and also because you need to pass parameters. But over here, the thing is that for map and filter, you do not need to use the parenthesis or pass any parameter, because it passes each and every element of the iterable one by one as a parameter to the to the function, and then it computes it, and depending upon the function it returns. And yeah, that's how you get things done. So this was your lambda functions. I hope lambda functions are clear, because lambda functions are going to be quite important later on. Lambda functions are basically lifesavers, because they reduce the size of the code. Especially for one line of code, it's quite inconvenient to create a separate named function. As for filter, I would suggest using filter. Now, an alternative for filter would be using a for loop or a while loop and then checking the conditions. But the thing is that filter works much faster than a for loop for Python. And the same thing with map. Map is basically applying the function that you give to all the values of that iterable. And this was pretty much it for this session. I hope all the topics were clear, and we'll proceed with Django if we have any more time left this session. Otherwise, this could be considered as the last session that the development department conducts for this session. Okay, and I hope everyone understood what we did today.